This section of notes is about the different types of bonds. There are several types of bonds that we're going to talk about in this section. Um, and so we're just going to go through all those different types so that you will be able to look at your compounds and identify the bonds that you're looking at. So first of all, we need to kind of understand what a bond is and why atoms come together to make a bond. And it's because they want to be stable. So again, they're most stable when their electron shell is full. We talked a lot about that last chapter. So that always means that we're going to have 8 valence electrons. Okay. This means that we are following the octet rule. Oct means 8, and so that means when that outer shell is full, we're following the octet rule, 8 valence electrons. There are 2 main exceptions. The one we'll use a lot is hydrogen, and it only holds 2 electrons. Helium is the same, but we really won't see that in too many compounds because it's a noble gas. I kind of went through this example last time too in the last chapter, but you can see here that sodium has 1 electron here in its outer shell that it wants to lose, so that it then has 8 in its shell beneath it. So this can be donated over here to chlorine, who has 8 in the shell on the outside here, the valence shell, and so then that would give that one a full shell also. Okay, so just a little review there. So remember, when that happens, when sodium loses that charge, it becomes positive, or excuse me, loses that electron, its charge becomes positive, and when chlorine gains that 1 electron, it becomes negative. So now we have a negative and a positive ion, and these come together and make an ionic bond. Okay, so things to remember again: cation is the positive. This is always going to be your metal. So you may want to add that into your notes, that this is going to be the metal, because the metals are going to be the ones that lose the electrons. And then our anions are the negatively charged ones, and these are going to be our nonmetals, because those are the ones that gain electrons. Okay, so a few things, just again, kind of a review from last chapter of things to remember. So now these 2 oppositely charged ions, the positive and negative, are going to attract each other and form that ionic bond. So what we typically say is that an ionic bond is going to be formed by a metal and a nonmetal. So right here, very, very, very important to remember. You've got your metal, which is your positive. You've got your nonmetal, which is your negative. They come together, help each other fill their valence shells, and end up with an ionic bond. So again, metals are going to have fewer valence shells. They have lower ionization energies. Metals then are going to lose their electrons. Nonmetals then are going to gain electrons, like we just mentioned. Again, metals become cations, nonmetals become anions, and these 2 together form that ionic bond when they're attracted together. Now, nonmetals are a little bit different. When we have 2 nonmetals come together, neither one is going to gain or lose. So instead of gaining and losing, they share electrons. So when they share, we can form 2 different types of bonds. The first one is a nonpolar covalent bond, and the second is a polar covalent bond. So you can see when we have 2 nonmetals that come together, these are going to be covalent bonds. Then when metals bond, typically it's just a whole bunch of electrons. We call it a sea of electrons, or a pool of electrons. They just share. The electrons are free to move wherever they want, and they're really not bonded to anything specific. They're just a big network. And so they've got all these electrons that just kind of move around wherever they want in between the metal atoms, and that's why metals behave a little bit differently than most of our other types of bonds. So bonds definitely affect the properties. The type of bonding allows different things to happen. Okay, so main point here is bonding affects the properties that we see, but there are always exceptions. You guys have learned that in science. There's always exceptions for everything. So when we look at boiling and melting point, this is one of our properties. Ionic bonds usually have very high melting points, and it's because it's hard to pull them apart, because they have those electrostatic forces, which are those positives and negatives that we talked about, that attract to each other. Normally, when we talk about ionic bonds, they're going to be solids. Polar covalent bonds, then, these have the next highest melting and boiling point, These can be solids or liquids under normal conditions. It just kind of depends. And then nonpolar are going to have the lowest melting points, and these are usually liquids and gases. Okay, so that should make sense that if something's a gas, its particles are very far apart, so it should be very, very easy to change its state. Solubility. This means whether they can dissolve in water or not. Okay, so another word for this would be dissolving. So when we talk about the different types of bonds and whether they can dissolve or not, ionic and polar do dissolve in water. Non-polar and metallic are insoluble or do not dissolve in water. So again, these are just properties you kind of have to remember and how they're connected to the types of bonds. Electricity, here for this to happen, charge has to be able to move. So in metals, where those free electrons are, electricity is conducted very, very easily. Okay, and you guys should know that when metals are solid, or actually in the liquid state too, they can conduct electricity very well, but it's because of those free moving electrons. Ionic bonds, when they're dissolved in water, meaning their ions are broken apart, so again, they can have free floating electrons in that case, so they do then. And then covalent bonds are never going to have a chance to conduct electricity because they don't have any ions. Okay. And that is the end of this section. So all those different properties are going to be very important to remember.